Welcome. So now we're going to use similar triangles to solve for some missing measures. If you remember earlier, I said that similar triangles have sides that are in proportion. So we can use proportions to solve. Right, you just have to match up the corresponding parts. All right, so we're looking for that distance there. Right, that corresponds with that side there. Trying to figure out a way to mark it. All right, so instead of question mark, let's put x. X goes with 5.4 as, now we just need another pair of sides. So actually, let me actually back up just one little bit. When you're setting these up, put one triangle in the numerator and one triangle in the denominator. So this is large triangle that's going to go in the numerator because that's what we are solving for. And that's how I was setting it up. But let me just go back a little bit and tell you, we're going to put the large triangle measures in the numerator and the small triangle measures in the denominator, because it doesn't work if you mix them up. All right, so you have to match, everything has to be matched. So x goes with 5.4, and then another side, we only know one other side in the big triangle, that's this right here. And that goes with that right there in the other triangle. All right, so we've got large triangle in the numerator, large triangle in the numerator, small triangle in the denominator, and we've matched up. X goes with 5.4, 6 goes with 2.9. Now to solve, you cross multiply. That's how you solve proportions. All right, so it means 2.9 times x equals 6 times 5.4. So 2.9x equals, so 6 times 5.4. I'm going to grab a calculator just to do that quickly. I can multiply big numbers in my head. I don't know what it is about decimals, not so much. I put the decimal in the wrong spot. Times, oh, oops, the wrong thing. We were multiplying 6 times 5.4. So that's 32.4. We're going to divide both sides by 2.9 to solve. So you're going to cross multiply, and then you're going to divide to isolate your variable. And let me just check, because this is not a very pretty decimal. We'll have to round. Nope, that's right. Divided by 2.9. I was hoping I misread a number. Nope, it's 11.17 and it keeps on going. We'll round to 11.17. Meters. Right, so that one's not a pretty decimal. You'll probably see pretty decimals. Right? And so that's really all we have to do to solve for missing measures using similar triangles, because the sides are in proportion. Let's do one more. This time, instead of the triangles kind of crossing one another, they're going to be next to one another. And this is a very common real-world problem. This one, by the way, the problem was solving for the distance across the river. That's using similar triangles to measure things you can't measure is a main purpose for real-world similar triangle problems. And this is something else we can't measure, right? We can measure someone's shadow. We can even measure the shadow of the windmill there because it's on the ground. But it might be hard to measure the height of the windmill. Right? So we have similar triangles here. And I like to put them in words when I've got a real-world situation here. Right? So we are looking for the windmill height. Right? Well, windmill height goes with person height. Notice I've matched height with height. What do I know? I know the windmill shadow. What does that match? That matches person shadow. Right, now notice there's a theme going across the numerator, across the denominator, and in each fraction. If there's not a theme, it won't work out. You will not have set it up correctly. So notice that height goes with height, shadow goes with shadow, windmill goes with windmill, person goes with person. All right? So if you write it in words, then you can look back and say, yep, I matched all the things correctly. Everybody's matched. Now we just plug in our values. So x and 5 equals, the shadow is 21, and the person is 3. You can reduce if you like. It's 21 and 3 reduced to 7. But I'm going to show you it doesn't matter if you reduce. Right? You've got the same answer either way. Cross multiply. 3x is equal to 21 times 5. So 3x equals 105. And if we divide both sides by 3, we get x equals 35. And if we had reduced, I'll just kind of put it over here. Right, so that would be 7 and 1, right? 21 divided by 3 is 7. 3 divided by 3 is 1. We'd have x equals, oops, sorry, my pen slipped, 5 times 7, or 35. All right, so whether or not you reduce doesn't matter. Either way, our answer is 35 feet. So I just want to show you a couple real-world examples of solving with similar triangles. And the next video is going to be the last video. We're going to look at triangle proportionality theorem. Thanks for watching. Bye for now.